Thanks very much, Lorraine, for the introduction and for the to the research committee who's invited me to speak with you today. Thanks to everybody who's given up their time to come. So today, as I've just recently joined the school, I wanted to give you an overview of the type of research that I conduct. So more generally, I've conducted lots of research in the area of nutrient management practices and the adoption of nutrient management practices. But my background is not as a soil scientist, and what I want to look at today is nutrient management practices, the projects that I've been involved in terms of benchmarking and where I see this going in terms of our school and the types of skills that we have here in our school. So I want to look at it in terms of addressing two kind of more specific questions. One is, well, what do social scientists and economists know about soil and how important that is in terms of our approach to research. So what do I as an economist know about soil and soil functioning, and why is it important that soil scientists and economists actually need to have conversations together to be able to understand each other. So that's kind of what I want to address, and I hope you'll come away with a more enlightened view of why this is important. Okay, so there's two concepts that I kind of have generally focused my presentation around. So one is the concept of sustainability. So sustainable farming and sustainable living, and the other is innovation. So innovation is obviously important in terms of change. These two concepts are thought of as quite fuzzy and ill-defined, but actually when you get down to the nitty-gritty of these topics, you'll see that they are quite concrete, and they're very valuable in terms of where we are going in agriculture and in food research. So not just at the farm level, but up the supply chain, right up to policy, where these types of understandings are really quite important. So first, I'm just going to give you a little bit in terms of my background. I'm going to look at some recent research and the implications of that. And then finally, I'll have a very brief look at the kind of current projects that I'm involved in. So on the left are just some collaborators that I've been involved with and am currently involved with. And I'm not going to spend any great time talking about the specifics of individual collaborations, but I'm going to focus on one project and try and give you a greater understanding of why it is important and how it meets with these sustainability and innovation concepts. So in terms of my background, I'm an economist. I have a background in economics and a master's in policy evaluation. So economics is obviously, the basis of economics is around the use of scarce resources. So this is something that ties very naturally with the natural sciences and soil science in particular. In economics, we're obviously very focused on efficiencies and driving and gaining maximum outputs from the inputs that we have at farm level. So during my PhD, I would have looked at the adoption of practices at farm level. So I looked at land management practices. So I looked at two suites of technologies or practices, grassland management practices and nutrient management practices. So I look at this not just from a scientific perspective, because there are lots of science out there that helps us to understand the importance of these, but I looked at it from a social science perspective. So actually we have the science there. So grassland management papers, experiments, etc. will tell us that we can gain advantages by performing these practices. But in reality, a lot of farmers actually refuse or are seen, at least on the surface, not to be using these practices, and this is a big issue. So science can't answer that, but through working with social scientists, we can help gain a greater understanding on the whole of what are the types of issues that farmers are facing. So my work's primarily in the dairy sector, and looking at these two suites of practices. So the three main things that I focused on was soil fertility. So nationally, soil fertility was falling, but the adoption of soil testing, for example, one of the key nutrient management practices, was increasing. So we wanted to look at this kind of anomaly to see what was the issue. So we looked at things like the communication of science and how we communicate our information to science in the context of this whole, I suppose, collective that we have from social science and from the agronomic side of things, we want to achieve sustainable land management. And how do we achieve that? So two ways in which I've looked at it is looking at nutrient use, but more specifically looking at nutrient accounting. So how do we account for nutrients in our soil? And then beyond that, actually, beyond the methodology of how we do it, who actually cares? So who cares about this and why is it important? So one of the big challenges that we face is obviously the importance of soil and the nutrients that it contains. So optimal nutrient soil status is desirable not just from an environmental perspective, but it's also important in terms of the social benefits. So soil is a key component in the water cycle, for example, so there are obviously social issues there that we need to take into account. So the contributions from agriculture can be obviously positive and negative, so we have these externalities associated with farming. But there can be gains to be had by viewing this as a topic that we can come together to bring a solution to. So oversupply of nutrients is obviously the major risk. And here we're really talking about a trade-off. So there's a trade-off between efficient use of resources. So we want to use the land optimally in order to gain maximum output, but we also want to respect our environment and also to be aware of the social implications of production in agriculture. So there are bigger challenges also that we must look at. So meeting with our food production needs, so our growing population that we're always being told about, how are we going to feed the world? But also to look at this in light of our risks that we pose, specifically to water quality, and that relates to on-farm application. And the risks are associated with losses, so losses to the aquatic environment, but also to the atmosphere. So what do we know? We know that farmers spend a significant amount of money on two key sources of nutrients at farm level. So if you add those two up, we can say that more than 50% of their expenditure is actually reflected in expenditure on two key inputs, fertilizer and concentrates. And this was a study that we did on dairy farmers in Ireland. And then more generally, when we look beyond the dairy sector, we can also see that it's not just dairy specific. So here we have finding from the FAO that actually positions Ireland topping the pole where we don't want to top. Basically, it says that we are the 4th and 12th highest users of N&P on a per hectare basis for arable farms. So all of these types of statistics, if you like, and there are many more, make us very much aware of the inputs that we need on the one hand, but we also must be aware of on the other hand. So there are costs and there are gains. And in economics, we talk about win-win situations. So a win-win will be where we can reduce the costs associated with production, but produce an optimum level of outputs. So there are gains to be made economically and environmentally. So in measuring then nutrients, we looked at benchmarking nutrients on Irish farms. So this project was funded by the EPA in conjunction with Teagasc and UCD. So the Agri-Benchmark project is almost coming to a close now at the moment. And essentially what I'm going to run through in the next few slides is what we actually did. So in the project, it actually incorporates obviously all of these actors, but it is seen as important because of the social implications. And primarily here we're talking about the impact on water. So this is just an overview of the project. This is the website that we have. And the aim of the project was to develop national benchmarks for two key inputs, so nitrogen and phosphorus, in order to kind of improve the information that farmers have at farm level. So how can we provide them with the information they need in order to help them to achieve more sustainable land management practices? So benchmarking is one option that we looked at. So within benchmarking, there are a number of different nutrient budgets and models that we can use. And as a first step in this project, we essentially evaluated the various different types of models. So this was done very crudely, if you like, by members of the team. And we essentially looked at, well, what can we achieve? So what was achievable in the time frame that we had? So we looked at data availability and data certainty. So there were the two kind of data criteria, and then we also looked at usability. So how usable is this for the farmer? So that was the key for this project, because our aim was to give something back to the farmer that was actually useful and beneficial. So in looking at the various different models, we decided that the farm gate balance was key, and actually our evaluation did form part of that decision, but the major driver of this was because the variables that are included in the farm gate balance are actually the ones that the farmer has control over. So they have control over how much they buy, they have control over how much they apply. So we thought that was the most appropriate method. So on any farm there are natural boundaries. So the agricultural nutrient boundary here is depicted by the darker outside border. And essentially there are inputs and there are outputs. So when you account for nutrient inputs and outputs, you would look at things like in the top box here, we have three key inputs of, again, going back to nitrogen and phosphorus. So mineral fertilizers, concentrates and livestock, but then there are also off-takes. So within the farm there are then interactions with the soil. So in terms of the soil, we don't have any data on soil. So we can't estimate things like, or we can, but with varying degree of certainty, things like nitrogen deposition or fixation and mineralization. Also, another key element in the Irish context, it's quite important in terms of our grassland-based system, is the organic manure that we use. Again, there are standard coefficients that we could use, but in this case we excluded farms that actually had imported organic manure. And the reason is that we don't actually have information on volumes. So all we have information on is whether or not they imported manures, organic manures. So for that reason, they were excluded. So what did Agri Benchmark do? We essentially focused on these farm balance boundaries, and we looked at the data that we had. So we calculate the average, or the kgs of nitrogen associated with each input, and the balance is essentially taking one from the other. So within this framework, the balance boundary, these are standardized balances that were developed with the NFS through the work of Carl Buckley. So he developed these indicators based on, or developed these balances based on existing literature. What Agri Benchmark then added was this benchmark, essentially, aspect of the project. So why we chose this level is important because we had information on the volumes. So volume is really important in terms of nitrogen, so the pressure, sorry. So the pressure that is at each farm level. And what we have in addition to that is farm level data around the socioeconomics of each farm. So this helped us again in developing the benchmarks. So as I said, the calculations were based on a previous literature. A nationally representative unbalanced panel was used in this instance from 2012 to 2015, and within this it should be noted that any farm with less than 8,000 standard output units were not included in this. So these farms are quite small in terms of their gross output, but in terms of their actual representation in the population is quite large. So predominantly these are farms larger than 8,000 standard output units. So the methodology actually changed. So for those of you who don't know, FADN is a farm accountancy data network that collects information at farm level across Europe. So we are obliged as a member of the European Union to submit information at farm level around the economics of farming. So in Ireland, we submit what's required by the European Union, but we also collect a lot of other additional data, which is hugely beneficial for research, and that's available through the National Farm Survey. So that's the kind of background of why our methods. So I'm sorry if you can't see this, I hope you can. This is basically the indicators. So the first one is an indicator of pressure on the environment. So what it does is it measures the kgs of inputs, so inputs in terms of N and P at farm level, and it essentially subtracts the outputs in terms of N and P. And we measure these in accordance with utilisable agricultural area so that we can have a per hectare kind of measure. The bottom, nutrient use efficiency, is an agronomic efficiency indicator. And essentially here you're using the same data, but you're looking at how efficiently these are converted into a percentage or a unit output. So here is just some of the kind of first key findings. I won't dwell on them too much, but essentially these are the balances and the use efficiencies. So here you can see, and it is similar across all years, that the dairy specialists are the kind of section of farmers that have the highest balances. So these high balances mean that there is greater pressure on the environment. And you can see here, as you would probably expect, sheep farmers having a much lower balance on a per hectare basis. So in 2015, again, you will see the same thing, but with this time, the tillage sector had a slightly lower imbalance on average. So what it was important here in terms of these balances was that interpretation. So up here at the very top, you'll see the use efficiencies of the tillage farmers. So when I would read that as an economist, essentially I would see that these tillage farmers are really efficient, right? So they're almost using, they're 94% efficient almost. So their use of inputs versus outputs is very efficient. But through working with Paul Murphy here and our postdoc, Ian Thomas, who are much more knowledgeable in the area of science, we began to have a conversation around this, which essentially looks at soil mining. So these are issues for optimum balances. So when you actually generate these balances, where should the optimum be? And we're kind of thinking in or around 70 to 90% might be kind of an optimum area which you would might like to be in. So for P, for example, having a 94.8% PUE, so use efficiency, is quite high, and farmers might be in danger there of mining the soil. Also with P, soil has the capacity, as I learned, to retain P in the soil, and David Wall in Teagasc has done quite a lot of work in this area looking at P banks in soil. So again, there are lots of different benefits from working with others outside of your discipline. Here we see that there were, here I'm just going to focus on the dairy sector because going through all 6 systems might take me a while. So just to give you a kind of an indication of change. In 2013 we had the fodder crisis. So within that you can see that there was a much higher use of inputs. So here the N balance associated with dairy farming in 2013 was significantly higher, and this is the case when you look at on a trend basis. You can see it a little more clearly. So you can see this peak in 2013. So focusing again on dairy specialists, again you can see that over this period of time that we're looking at, 2012 to 15, the EPA reports would suggest that a monitoring status of our water quality is quite reasonable, so we're reasonably satisfied with that. But this only goes as far as 2015, and obviously in 2016 we had the expansion of the dairy sector, and this is something that we will be looking at going forward. So for future pieces of research, we'll be looking at how these balances actually change in the next 5 to 10 years. And in 2016, we also must see that we've actually expanded somewhere in the region of 18% already. So we're expanding faster than we actually anticipated, and what are the kind of consequences for the dairy sector, but also for the wider environment in that sense. So they're the measures as they stand alone. Then we must look at actually, well, how do we make them readable, and how do we benchmark farms? How do we communicate this information to farmers? So telling a farmer his balance is 150 kgs of N per hectare means absolutely nothing. So we need to try and communicate this more effectively. So one of the ways in which this project the aim of this project was to develop these benchmarking metrics. So this is a diagram which just depicts on the bottom axis your N balance. So here you can see that the average, which we've seen in a previous diagram for farmers, is in or around 150 kgs of N. So you can see the glut of the population is in or around this region. So we picked the variable milk solids because in the dairy sector, farmers are paid in terms of the solids of milk. So they're paid on a milk solids basis. And if you look at the average, what you can see here is that there is plenty of room for improvement. So you can see here that the farmer who has 100 kgs of solids per litre of milk versus the farmer who has less than 200, so in around 150. So you can see there that essentially there is a huge scope for improvement. So moving from 900 down to 150. So these ones at the bottom are less efficient, but the pressure on the environment is actually the same. So when you look at these types of data, you can very clearly see that there is room for improvement. So how do we actually address this? So we measured or looked at a few different benchmarks. This is just a year-on-year basis, but again, we're looking at kgs of N per milk solids. And we look at the peaks, which we can see has been in 2013. Again, this is in relation to the fodder crisis. Another metric that we use is looking at gross margins or family farm income. So again, this is possible because we have the socioeconomic data from the National Farm Survey. And what you'll see is actually the bottom earners. So if we categorize income in terms of bottom, middle, and top, we can see that the bottom earners actually have the highest surpluses. So again, they pose the highest risk potentially on our environment. So again, something that we need to consider. Same thing, this is just in terms of soil classification. So we only have 3 classifications of soil in the NFS, and if we classify them in terms of soil, again, we can see they have the lowest balances for poor performing soil. So they're the lowest, they're less environmentally risky, if you like. So then how do you design a tool? So we must look at interpretation and why interpretation is important. So it's important that they get the message. So we wrote a paper previously on a farmer's perception versus proven science. So essentially it means that we must kind of try and work together to communicate this science effectively. And how do we actually do this? So one of the key aims in this project was to incorporate it into existing tools that we have because of the short-term nature of it. And essentially this work isn't something that's extraordinarily new, but it's just about fitting it into an existing tool so that it gives the farmer a new way of looking at a balance. So in terms of a balance is fine, but we need to make it a benchmark so that he can target where he needs to move and the direction he needs to go in. So one way of doing this is looking at what they're called our innovation toolkits. So you provide the person with the information and they then are enabled to interpret their own performance. So this kind of idea of self-regulated monitoring that you get involved in that. So this reflects, again, our economic and environmental value to the farmer. So it's not just about knowing how to do something, but actually knowing why is equally important. So this is one of the metrics that we looked at, and essentially all of these points are gross margins per hectare on dairy farms, and they're split into percentiles. So we have 4 different basically regression lines that run through our data. And what we are looking at the moment is strategies. So for a farmer, what does he actually read from a diagram like this? Where does he need to be? So we arbitrarily drew a box in this region, which you can hopefully see, which essentially is where we believe is the optimum area for farmers. So the idea that this farmer at the top here needs to move in that general direction. And why we divided it into these quartiles is that the idea is that you're making a progressive or an incremental change which will help you move towards the optimum. The elephant in the room here is the fact that we actually don't know anything about these farmers' soil status, so their current soil status, which is a big issue, because essentially we are making these types of benchmarks in a vacuum without this information. So this information is really important in terms of the science. So what we are suggesting is that we take the work that's been done in Teagasc using their NMP online framework, which is designed by David Wall and Mark Plunkett, and a whole host of other researchers in Johnstown Castle. So it's been online. So Stan Lawler had an input into this, along with a lot of other individuals and researchers. And essentially, this would give farmers an opportunity to plug in that data. And our benchmark, or our diagrammatic benchmark, would be an additional output for the farmer. Okay, so now I just wanted to talk to you a little bit more generally, so about looking at these problems. So there are accepted kind of ways in which we can address these problems, but generally it's kind of around a more focused approach or a targeted approach. One of these examples is the Agricultural Catchments Programme. So this is a regionally based programme in Ireland that focuses on monitoring water quality in an area. So there are 5 different regions all around Ireland. Essentially these types of programmes have huge benefits for the farmers, but also for the researchers. So the researchers have data on a daily, weekly, monthly basis, and they can provide evidence to suggest that water quality is improving or disimproving. They also have advisors on board, so it's an interdisciplinary team of researchers that are involved in this, and the advisors have the contact with the farmers so to try and help them improve their water quality. As well as that, it actually gives the farmers a little bit of a, I suppose it gives them feedback initially, because they know how their water quality is performing. All of these catchments have rivers through them, so their core aim is to improve productivity. So they monitor productivity, but also to be conscious of their water and improve their water quality status, including rivers and lakes. So these types of approaches are hugely beneficial for looking at these problems. So the science exists, but how do we actually work together to improve it? So we want to look at reducing our inputs, but also sustaining our levels of outputs. And research experiments exist which will prove that, but we need to raise that up to a national level, so we need to look at increasing them in terms of scale. So I'm just looking at 2 different projects here. One is a Smart Grass project, which was conducted here in UCD, which looks at various different uses of grasses and how we can attain equivalent levels of productivity whilst reducing our inputs. So these types of experimental projects are really important and insightful. And this is another example from Origin Enterprise in the UK. So they have a farm in Northumberland in the UK, which essentially broke the world record for wheat production with using less than, I think, 3/4 of the levels of inputs. So those types of projects and experiments prove that this can be achieved. But it's about rolling it out, and it's about actually looking at what we're dealing with to effectively improve our productivity whilst protecting our environment. So what we begin to think about is actually, well, is the message lost then, and what are we doing wrong? So this is from national records in Ireland, so it looks at soil fertility. So essentially you can see these 2 bottom lines in the red and the blue have an upward sloping curve. And this is a trend that has continued. So this only reaches 2011, but more recently this trend has increased dramatically up to 61% in 2015. So essentially soil indexes range from 1 to 4. 1 and 2 are suboptimal. 3 is the optimal area, so where we want farmers to be at is somewhere in the region of an index 3 field. whereas 4 is oversupplied potentially. So there we can make savings. Again, the win-win situation, the economic and the environmental win. But what we're seeing is this increasing trend in the lower classes of soil. So this is something that's been, it's something that we need to discuss realistically and actually to think about, well, what is the implication of this? So how are we going to deal with it? Policy is one of the big drivers of change, and in the past we've seen lots of different policies that have regulated the conducting of soil tests. So for example, REPS, AOS, any farmer who's in a derogation, they must all actually have a soil test done on their farms. But it just kind of begs the point, or begs the question, then what are they doing with these soil test results? And are they doing them just for the sake of policy? And are they actually, should policy be rethinking how they are promoting the adoption of these practices? Or should they just stick with the regulated effect where just it mandates the use of these practices? So it mandates use of, but it doesn't actually improve potentially understanding of. So this was one of the papers that we wrote on based on that. So essentially it looked at so these high rates of soil testing by Irish dairy farmers, but nationally our soil fertility is declining. So we have 70% rate of adoption in terms of use of soil tests. And what's even more worrying is when you look at this is just the descriptive data, so essentially looking at the difference between soil test users and non-soil test users. And what you can see here are for the bottom dimensions, so fertilizer, concentrates and direct use, that there's actually no significant difference between how much they spend on fertilizer. So whether a farmer is soil testing or whether he's not, he's essentially on average spending the same amount on fertilizer. So this is worrying for the guy that's not soil testing, so he's spending the exact same amount on his fertilizer. So it again kind of asks us, or kind of presented a number of questions with us. Prior to conducting the study, we thought obviously the soil testers would be more efficient in terms of their input expenditures. So we made some suggestions as to why. So the first one was that, well, maybe they just fulfill their obligations but may not use the results, so that is a possible. The other possibility was that farmers only test poor quality soils, but probably unlikely given the trend has been there since the early 2000s. The third one is that they might not wish to achieve agronomic optimality, which is a possibility. Maybe they're not motivated by optimizations or maximums. The fourth, we looked at policy, so the legislation. So legislation that prevents farmers from prevents farmers from using an unlimited amount of inputs, chemical inputs in particular, under the Water Framework Directive and the Nitrates Directive. They would be restricted. Another reason might be mixed messages, so getting messages from different sources, multiple sources of information from the wider economy, or from the wider environment. So it could be from your peers, from industry, or from media, for example. So maybe there's conflicting information out there. Another thing that we need to consider is that, well, soil tests actually don't take into account everything. So inherent characteristics of soil, for example, are not taken into account. So root development or water retention capacity, they're not taken into account by soil tests, but they might be something that farmers take into account when they're making decisions potentially. So just some suggestions or thoughts. So when we're looking at the grand challenges for agriculture, I think personally sustainable land management is one of the top priorities because soil essentially is a non-renewable and our land area is limited. So we have a finite area of land upon which we want to produce. The other key one I think that we need to think about is climate change. And we've seen that in 2013 from the previous slides that this fodder crisis, which was based on weather events, extreme weather events, does have a significant impact on how we actually act and how we farm, etc., etc. Beyond that, there are societal challenges which incorporate the above too, and that really reflects water. So our water sources for the wider public, but also for the provision of environmental advantages like air quality, etc., etc. And the big thing, what I think we should think about is actually the costs associated of inaction. So what are the costs associated with inaction, and how are we actually dealing with it? So are we burying our head in the sands, or are we actually thinking, okay, we need to deal with these issues? So Mertens looked at, and prior to Mertens, Rittel and Weber in the 70s looked at this idea of wicked problems. And I think wicked problems is a good term for us in agriculture to think about these various different issues. So wicked problems involve these interacting systems with social and institutional uncertainties for which there is imperfect knowledge about their nature, but there's also imperfect knowledge about their solutions. And I think us as researchers, we should try and deal with or grapple with some of these wicked problems. More recently, there have been called super wicked problems. So super wicked problems have additional characteristics. And again, I think they are important for the agricultural sector. So having a lack of a leading authority in an area. And the reason there is a lack of leading authorities in this area is because they are so complex. So these issues are not just water related, they are not just soil related, they are not just economics related, they are very integrated problems. So having a central authority can be potentially difficult, but I think policy is one area in which needs to encompass all of these. But again, our engagement with policy and how we influence political decisions is obviously important. Policy, so policy often, because of the political element involved, has this kind of short horizon or short-term view of the world, whereas we need to look at these things for the next 100 years or for the next 150 years, for example. So if we're really serious about dealing with them, we need to think more long-term. And one of the big things here is that time is running out for us, and so how long do we have left? So when you look at innovation and interdisciplinary research, there's lots of thinking between cognitive distance. So Noto Boom is one of the leading areas in this, one of the leading researchers in this area. And essentially he looked at interdisciplinary research and the advantages for innovation. So what he found was that there was a much higher or positive effect when engaging in more radical or exploratory alliances rather than just your kind of exploitive alliances. So to think beyond just who you are aligned with in terms of your skills, whether they're your technical skills or your soft skills, but beyond that. What do I know about soil? Well, I dig it, but I don't dig it physically. So I understand the importance of impact. So what does social science and soil science have in common? I think it's in terms of impact, and I think that's where we need to be focused on. So where do we focus on and what do we focus on is one of our big challenges. So for example, if you take the rates of adoption in Ireland, so 70% adoption rates with increasing numbers of samples in these lower categories. Well, how are we actually going to deal with this problem? So policy, what it does is it mandates the use of a practice. So it mandates the use of a practice by including it in, for example, the REPs. So it means that farmers act purely because of regulation. So they do it because they have to. And that's not the real innovation. So the real innovation, and when you look at defining what innovation is, you really, from my perspective, you must look at successful change. So successful change is not going onto your field, taking the soil sample and getting the results back. Successful change is actually moving toward that optimum fertility level, for example. So the rewards in policy, I believe, should be focused at outcomes and at impact level so that we can actually influence real change. And this is also underpinned by the communication, so how we actually communicate this message to farmers, so knowledge communication. So for what purpose do we actually depend on each other, and what is the gain? So I think before we go into bed with somebody, we should have on the table everything that we are gaining from these types of partnerships, or from these types of strategic alliances, if you like. So who are we gaining, and what do we want to achieve? So knowledge exchange and communication of science, which I've already kind of spoke to, is one way in which we can come together. Given that we have the science, how are we actually improving how it's communicated? Knowledge exchange is very different from knowledge transfer, in the sense that when you think about advisory services, they're moving towards learning. So advisory services are learning from the farmer. They're learning about the challenges and helping them to overcome. So we have knowledge. Obviously the science is there. It's a proven science, but it's actually more effective if we can work with differences between users. So if you look at adoption literature, even in IT systems or in any various different discipline, they're becoming more focused on end users. So the focus is on user needs, and how do we meet with user needs. So those types of topics are important. So this is again looking at the interdisciplinary nature of what we face. So from these three perspectives, sustainability is made of three key pillars. So from an economics perspective, this is taken from the Flint project that I was involved in. We were looking at things like income support, income stabilization. So income support and income stabilization are very important in terms of volatility of prices from a farmer's perspective. But predominantly within the economics, we're focused on the production of goods and services. From an environmental perspective, we're obviously focused on resource efficiency. So things like climate and soil, water quality, biodiversity and energy are big topics in that area. And predominantly here, the focus is around managing our environment. And then finally, socially, what does it mean for agriculture? So this is looking at sustainability at farm level. So from a social perspective, we're looking at things like contribution to rural dynamics, how well integrated the farmer is in his environment, so to help them improve their well-being, improve their decision-making, and things like social engagement was actually quite important, because we found that rural isolation is a big issue. So this is one of the more recent things we've been hearing about, the latte tax in the last couple of weeks, and I began to think about actually what are we trying to achieve here from the latte tax. So from an economics perspective, we would always say tax. So tax means instant change in behavior and revenue. But actually, when I began to think about it, and I've heard some clips on the radio about how people are reacting to this, and a lot of the time people are acting because of convenience. So will this tax actually prevent you from drinking your latte or getting your latte in a mug? They're driven by obviously two big trends. There are consumption trends around convenience and also our addiction to coffee, I suppose, really. But if we were to think about it in terms of a real solution, when we step back from things, is tax a real solution to the problem, or is this again an example of potentially a shorter term view of the world? So what do we want to actually change? So we want to change what we are consuming or the type of product that we're purchasing in. So one of the, actually, and I've seen this just down in Windy Arbor, so the drive-through coffee, they now have compostable cups. So these compostable cups come from a company in the UK called Vegware. And essentially what I'm trying to get across here is that, are these taxes short-term views, and are they actually addressing the kind of the broader, the bigger ideology of reducing and reusing and recycling what we're actually wanting to reduce in the longer term? So this company also produce products, many different products that are all decompostable. So essentially a movement towards something like that might be a better option, in my opinion, as opposed to a kind of a shorter term solution that looks at taxation options. So again, policy is hugely important. So I'm just going to give you my last 3 slides, 3 frameworks that I've toyed with. So one is a motivations type framework, looking at attitudes. And the second is action-based, so looking at actions on the farm. And the third is social influence. So why are farming objectives important? So they're important in terms of what motivates farmers to do. So within this experiment, we looked at principal component analysis, looking at experimental orientated farmers, conservative orientated farmers, and productive orientated farmers. And what we found was that these conservative oriented group were much less likely to conduct these kind of maximizing practices like grassland management, for example. So motivations are really quite important when we're looking at these issues. Organizational routines are another means or mechanism or theory that we can use to understand activity. So organizational routines defines a farm as a firm, and through defining a farm as a firm, we look at a broader range of literatures. So looking at management literatures and how we change what we do. Routines are defined by Nelson and Winter in 1984. They look at ways of doing and ways of determining what to do. And essentially what they look at is decision making. Within economics, we think of decision making as a binary decision, so it's a 1-0. So you either do it or you don't do it. But actually, in fact, we do things with varying degrees, or to varying degrees. So they identified 2 aspects of routine, so how we perform things. So the ostensive part, so for example, doing the soil tests, and the performative part, so how we actually use it. So ostensive and performative aspects of routines are important in terms of if you want to be involved in an intervention for change. So intervention for change is not just at the 1-0, the binary level, but it's actually at the performative level as well. So by using theories beyond your own discipline, again, you can find kind of further insights into addressing change. So here you have the ostensive part of a chemical applications routine, but then you have actually what happened in reality. So depending on the resources, depending on what happened throughout that year, etc., etc. And finally, this is a social influence model. So this is looking at 3 different aspects of social influence and how this can affect change. So Herbert Kelman did some work on looking at attitudinal change post-conflict. So after conflict, how actually attitudes to the other side changed, and he looked at the depth of motivation for attitudinal change and the key social influences in that. So he identified 3 different social influences. One is the compliance effect. So the compliance effect is specifically looking at rules, so mandated use of practice or mandated change. So we all have to drop our arms tomorrow. But what does that mean? Because I just shot your brother yesterday. So does that mean I'm suddenly going to change my attitude towards you? Potentially not. So compliance effects essentially look at rewards or avoiding punishment. And the stability of that type of strategy really depends on the ability to survey. The second way is identification. So if you identify with others in a system, this is feelings around roles, so specific roles. So if you have a particular leader in power, they might have an influence on how you act. Equally, a farmer might be influenced by a particular advisors or by a particular researcher. So you feel you kind of have to do something in order to maintain that relationship. So if you have a respect for an individual and they suggest you do something, you're influenced by them. But thirdly is this last part where are at the level at which we want change, so a change in values. So how do we actually get to this internalization stage? So we need to encourage people to change their values around our environment and how we can achieve economic advantages, but also achieve environmental advantages as well. So these are 3 interrelated but analytically separable types of concepts that we can consider kind of in our future research. So just to kind of wrap up, what I want to emphasize is that knowing how is important. So knowing how to do something, but knowing actually why you're doing it is much more important. And this is important in terms of our role as researchers for scientific communication. So complex problems that we face are much better solved through interdisciplinary research. And also it's about tailoring needs. So tailoring our solutions to meet with our user needs. So you can think about it in terms of the people who are consuming coffee. So how can we meet with their needs but also contribute positively to our environment and maybe economically by maybe supporting coffee shops that have these disposable cups, etc., etc. So it's about being a little bit creative with our policy and not just using the kind of shorter term solutions. And beyond that then, policy also has a role in terms of nationally looking at applications at a national level. So our solutions from an experimental point of view, from the natural sciences, how do we actually augment these and implement them at a national level? So it's one of the big kind of challenges. And I think that's kind of underpinned by two things. One is kind of a meaningful change. So are we actually committed to this deeper level change and how we can have meaningful policy? And understanding how, I think, is my last key point. And they're the two projects that I spoke about earlier. So these are just some research projects that I'm involved in. So AgriBenchmark I brought you through, and these are two other projects that are currently getting off the ground. So looking at environmental indicators using the land parcel identification system and the NFS, and also more recently an ICOS project looking at learnings from the dairy sector, and finally a project looking at co-design. So looking at co-design of knowledge transfer approaches, and this is a MAIS student here in UCD. Okay, so thank you. If you have any questions.